Okay. Good morning, everyone. It's a great pleasure for me to be here today, and I thank you for the invitation. Let me introduce myself in a second. I'm Sophia Giampieri. I'm a criminalist, specialized in technical crime scene inspection, and I'm currently a law student in Genoa, in Italy. Today, we are going to look at what BPA is, especially how blood spots are formed and affected, which will then become a study of BPA. Blood pattern analysis is a crime scene reconstruction technique based on the assessment of blood traces present in a crime scene. To reach a comprehensive assessment and conclusion, it's necessary to consider a series of factors such as shape, size, volume, number, and also distribution, location. And the BPA therefore deals with the study of the morphology of the quantity, the position, orientation, and distribution of blood traces found at the crime scene, aimed at determining the dynamics of the criminal event. Essentially, each spot or set of spots called a pattern contains information about the action that generated. As you can see in the other slide, each blood trace inevitably carries with information about its origin.
It's not just hold on, I want to watch the next
The BPA is divided into qualitative and quantitative. BPA can be qualitative when it empirically describes the mechanism of blood trace formation based on case studies and laboratory experiments, while quantitative when it describes the mechanism of, I hear something, is all good? Okay, I said. Quantitative BPA is when it describes the mechanism of blood trace formation through mathematical and physical models to establish the area of origin. Before proceeding, let's look at some characteristic of blood and also, sorry, I'm going too fast. Okay. And also how it behaves. Like blood is a colloidal fluid, that is, it's a fluid that has a suspension of solid particles in a liquid, where the solid particles in the case of blood include red blood cell, white blood cells, and platelets, while the liquid part is made up of plasma, which in turn is made up of 90% of water. And relative density, viscosity, and tension, in particular surface tension, these three I mentioned here. The relative density is defined as the ratio between the density of the body under examination and the density of distilled water at 4 degrees centigrade. Viscosity, instead, is tendency of the fluid to remain cohesive. Viscosity is the direct result of the forces of attraction between molecules, and in the end, it decreases with increasing speed. And finally, we have, as you can see, when I say before, viscosity. And finally, we have surface tension because blood, like any other liquid, is held together with cohesive forces that produce surface resistant to penetration and separation, a phenomenon called surface tension. And a drop of blood before detaching from the object on which it's located increases its volume until gravity overcomes the surface tension, thus allowing the blood to detach and settle elsewhere. By raising the cohesive forces that hold the blood together with different type of energy, the surface tension breaks down, and the patterns that can form are three different patterns. Like the first one, We can find a passive pattern, like when the only forces acting are gravity and friction, that is, drop of blood in free fall. The second one is splatter, when external forces also act together with gravity and friction, as we said before. And the last one is altered because when a physical alteration of the blood occurs, we have this type of pattern. A drop of blood doesn't lose its shape until it impacts a surface or is subjected to a force. In fact, when a drop of blood hits a surface, external actions intervenes that change its spherical shape. It's depending on the impact velocity, inclination, mass of the droplet, and the type of surface, obviously. The final result of this is that we obtain a blood trace, which, if analyzed individually and in the context in which we find it, can provide us with important information, such as, for example, the direction of origin, the angle of impact with the impact surface, the possible origin of the traces, and a lot of other information. And even before the blood traces are subjected to BPA, the traces are preliminarily examined during the inspection because at this stage, the technician must, first of all, establish whether the stain is actually blood. So you have to making a diagnosis of the blood nature, which is obtained by demonstrating the presence of the fundamental constituent of the blood, such as red blood cells and hemoglobin. Then he had to establish whatever is human blood. This type of investigation is carried out by identifying morphological differences between human red blood cell and red blood cell belonging to other animal species. And in the end, he had to establish the age of the stain, that is, establish how long the stain has been deposited. So the chronological diagnosis in question is based on the analysis of the enzymatic activity and also the analysis of the behavior of agglutinins, which are type of antibody, and the presence of antibodies that allow us to date more precisely. Within a crime scene, we can find many different patterns that originate from different dynamics, but unfortunately, today we don't have enough time. So let's just look at the factor that influence the appearance of a stain and its formation and all the process. For example, what are the factors that influence the shape of the stain? The shape and width of the stain depend on several factors that vary from case to case, such as the height, the volume of droplet, the affected surface area, and the angle of impact. Experimentally, we try to establish a relationship between the shape of the spot, its extension, the type of surface, and also the height of the fold, for example. A drop, like with a reference volume of 0.05 milliliters, produces a stain or a sketch having a diameter that grows proportionally as the height from which it falls and the surface on which it impacts increase. This is because the acceleration of gravity causes an increase in the kinetic energy of the droplet at the time of impact. Higher kinetic energy during impact is more effective in overcoming surface tension and thus producing a larger drip size. The nature of the affected surface, on the other hand, influences the appearance, like therefore size and shape of the stain, because irregularities in the substrate can cause like an irregular outflow of the blood contained in a drop. Different type of surface can be distinguished, as I mentioned here, like smooth. Can we have smooth, raw, porous, and made of different materials like paper, fabric, glass, and also wood. If you drop a drop of blood from the same height onto substrate of different nature, you can observe a substantial difference in the contour of the spots that form, like the spots that forms on a raw substrate as irregular edges, which may resemble lace that have thin, sharp tips with distortions which radiate from the body of the spot towards the outer edges, surrounding areas. And in addition, small peripheral splashes can form like around the spot. Here we have a presentation of blood drops falling from different heights, from alpha meter to 3 meters, impacting on different materials. So, for example, starting from the left, we see the behavior of the blood drops when they impact on a standard smooth surface. While in the second column, we have the behavior on a floor, and then paper, then a napkin, and finally a fabric. That the most important material because it tends to expand the volume of the drop as a consequence of being an absorbent material. In general, a drop falling of an horizontal plane vertically with respect to the surface, like 90 degrees, generated a spot of essentially circular shape. And as the inclination increases, therefore going towards an inclination of 18 30 degrees, the shape always turn out to be increasingly elongated until it turns out to be oval in shape with extensions. You have projected a table that reports in a very general way the various impact of various impact angles and the relative shape that we will find on the impact surfaces. So, as to summarize what we said before, with an angle of, for example, 90 degrees, we will have a circular shape. Going down to an angle of 18 degrees, the morphology of the drop remain almost the same, and therefore no major changes are recorded. Going instead towards an angle of 18, 14 degrees, we will instead find an elliptical shape, or at least a more elongated to end up then with all the angles of impact less than 40 degrees, which give us, as a result, a remarkable elongation that ends with an extension at the end. And here's an image. I hope you can see it, of experimenting what I said. Okay. No, I'm going too fast. Okay, that is because when the drop touches the surface, it does so only with its final part deforming, flattening, while the upper part remains spherical until it turn touches the plane. At this point, the drop flattens and collapses towards forming an edge, giving the shape of the spot, which at a later time will allow to the expert to reconstruct and determine the angle of impact, for example. The dispersion of the blood will obviously be proportional to the volume of liquid contained in the drop. Was already mentioned above to the impact velocity. The determination of the sequence of event will be based initially on backward reconstruction and an objective examination of the scene. The point where the most blood is found, so the one where we found the most patterns of blood traces coincides with the place where the attack carried ends. And conversely, the place where the least blood will be found will be considered the starting point of the criminal event. So, despite the importance of BPA for investigate evidentiary purposes, the fact remains that BPA's interpretation of the traces is quite subjective, since, as we saw here, the patterns generated are all quite similar. And above all, there can be multiple dynamics that generated them, thus risking leading the analyst to an incorrect conclusion. Then the other problem is that there is the lack of universal standardization of analysis method, and these limitations have raised doubts about the reliability of the BPA, especially in case where it has been deemed the primary means of proof leading to conviction that were later overturned or criticized. The BPA technique can also be used when the location where the incident occurred has been exposed to fire. Criminals aware of forensic technique may employ evidence hiding methods aimed at leaving no trace of the crime that forensic investigator can uncover. Like arson, for example, the deliberate setting of a fire on a property can be a modus operandi for concealing evidence from violent crimes, including murder, and has the potential to destroy physical and biological traces. However, fire in buildings are often extinguished by firefighters before the structure any evidence are completely destroyed. So in this case, however, we clearly have additional variables to consider as fire as important extractive properties. Consequently, it's able to alter both the internal structure and external morphology. In this scenario, it's therefore appropriate to make a distinction between a crime scene with blood traces actively exposed to fire, and a second scenario when a crime scene with blood traces passively exposed to fire. In the first case, the biological traces are directly and massively affected by the mass of fire and heat that acts of the biological matrix, obviously, also consuming it completely and causing profound alterations, like both in external and internal structure, as we saying before. In these cases, since the traces are totally erased or profoundly altered, is currently impossible to use the BPA technique for investigative purposes, because the traces are classified as unusual. Instead, in the second case, that of a passive exposure, it's possible that a good part of the blood traces are not destroyed or rendered unusable by the action of fire. In that case, it's still possible to apply the BPA technique for investigation. But obviously, BPA technique will have to be reviewed and adapted to the scenario, in the sense that, for example, the mathematical formulas that underlie trajectory calculation will have to be reviewed, just as the occurrence margins will also have to be revised. And experimentally, the impact of high temperatures on the morphology and analysis of blood stain pattern was examined. Um, this examination was made using controlled fire exposure. Blood stains before and after fire exposure were analyzed on various substrate, including glass, painted drywall, and painted plywood. That show that impact angle and area of origin measurements were conducted using a special software called Farozone 3D Expert software. And despite physical changes due to exposure to extreme temperatures, some characteristic of the original blood stain persists. Impact angle calculation showed minimal deviation between pre and post-fire measurements, with standard deviation generally less than 2 degrees. Estimates of the area of origin also showed no substantial statically difference between pre and post fire data, and the study confirmed that bloodstain pattern maintain observable trait despite exposure to high head conditions, supporting the reliability of BPA in fire affected scenarios. However, when traces of blood are hidden due to a fire and covered by a soot deposit, detection using traditional detection technique may not be effective because fire fumes can cover and preserve traces of blood on walls, for example, on ceilings and other surface, creating like protective layer. But however, excessive salt covering bloodstain can cause significant interference when using chemical reagents in the recovery of this type of tests. Non-destructive optical enhancement methods are often ineffective, I'm sorry, because due to the carbon layer above the bloodstain. Before the previous decade, any soot-covered physical and biological residue from a fire was considered ineffective. As a result, the situation led investigators to neglect the recovery of traces of blood remaining at the scenario. This way of thinking was based on the assumption that the evidence exposed to the conditions of the fire will degrade and wouldn't allow the effectiveness of more general investigate technique or wouldn't produce significant results. But more recent studies, however, suggested that various forensic techniques can be used to visualize, enhance, and collect also fingerprints, DNA, and blood traces from fire-affected sites, even when the fire involved a flashover. Also photography is often considered a primary source of evidence preservation from various forms of physical evidence due to its non-destructive nature. In particular, infrared radiation is composed of longer wavelength and has ability to, I'm going, okay, in that slide has the ability to penetrate through some visually opaque media, making the underlying latent material visible. Infrared radiation has also the potential to distinguish between two different objects that appear optically similar under visible light due to the difference in a spectral response of materials irradiated by infrared radiation. This is a metameric effort has significant value for forensic investigation at fire scenes because when a material is photographed using infrared radiation, we can have three different possible recording results. The first one, for example, is that the material can absorb infrared radiation and become darker. The second one is the material may reflect infrared radiation and become clear. So the opposite I said before. The last case is that the material may transmit infrared radiation and become transparent. So, in conclusion, however, this technique of reflected infrared photography has been successful in detecting latent blood spots under a thick layer of soot. This success was achieved by combining the spectral responsive of four parameters required for this technique, like including increased infrared absorption, property of blood after heat exposure. Another parameters is infrared transmission and penetration of the soot layer. Also like infrared reflection of the painted background and digital camera sensitivity. So it's very important technique and very new technique.